everybody. Welcome to day 2 of track 2. I hope you enjoyed yesterday's evening events and are ready for more great talks. Have you ever wondered if your CA policies actually work as intended? I certainly have, and so did our first speakers. So please welcome Fabian and Dirk-Jan.
Thank you very much. I hope a lot of you attended the 10K run and you got a lot of money together. Woo! Yes, welcome to Finding Entra ID CA Bypasses the Structured Way. Quick intro, my name is Fabian Bader. I work for Klückanja. I live in Germany. I'm a cybersecurity architect and do a bit of research in my day-to-day job. I'm also a Microsoft MVP and a first-time speaker at this nice conference. Last day was already very good, and I'm looking forward to today. And yeah, I'm also an organizer of a user group in Hamburg about security and have written a few little tools. And now to Dirk-Jan.
Right, good morning. I'm Dirk-Jan. I've been here a couple of times. Troopers is one of my favorite conferences still, so always happy to be back here every year. Yeah, I've given some talks before on these kind of topics. So I talked about primary refresh tokens or the Entra stuff, which is also something that will come back today. So I hope you already are familiar with some of the work I put out. If you're completely fresh to everything Entra, then maybe you will have a hard time at some point. But yeah, we'll get there, and it's going to be a fun talk today. Yeah, so I'm from the Netherlands. I have my own company since a few years. I write tools, and basically that's it. So let's start with the talk of today. So what I'm going to talk about, first we're going to do a short introduction, just to make sure that everyone knows all the terms, because if we dive right into everything, then everyone's going to be like, what's this? So short intro. And then we're going to talk about what we wanted to do with this research, how we came about to this research, and basically some unstructured analysis that we did previously, talking about some conditional access loopholes or limitations, basically. And then we move into the actual structured approach, like doing it at scale, doing it with a more idea behind it, rather than just trying random things and seeing if they work or not. And then first talking about finding all the apps and what actually the apps are that we can use to maybe find these bypasses, and then actually about finding the bypasses themselves. Then we'll also talk about some of the findings and basically the conclusions, what you should be aware of. So before we talk into going into the deep dive, I want to talk a bit about OAuth. Sorry, I'm not going to talk about everything OAuth, but when you talk about scopes and about OAuth tokens, then we need to know these terms. So very important one is client and resource. So in OAuth, a client is like the client application that you're using, and the resource is the server that you're accessing. So like Graph can be a resource, Exchange can be a resource, and that's where you get your tokens for. So client and resource is something that's relevant in every OAuth flow, and we'll be doing quite a few OAuth flows in this case. So this is a bit abstract. Let's make it a bit more concrete. Let's look at the example of Teams. So Teams is a client. I sign in to the Teams application on my device, and then Teams will talk to Entra. It will request tokens, access tokens, refresh tokens, ID tokens, whatever it needs. And Teams, as a client, will use these tokens to talk to the resource server, and it means that it gets tokens for Teams, the backend, for example, where my Teams messages are stored, but also for other resources like Exchange and SharePoint, because Teams, yeah, it uses pretty much all the resources that exist in Microsoft 365. So Teams is the client. It's the client application, and the resources are these APIs. Now, this combination of client and resource, that's something that you see in all the sign-ins. And basically every combination of client and resource will give you a token with a specific scope. And the scope of the token is what that client is allowed to do on your behalf towards that resource. So it kind of limits what each application can do. Now there's a few scopes that we see very often, like these graph scopes, mail read, user read, basically tells the client, okay, this is what you're allowed to do, and the resource server will limit the access for the client based on what kind of scope that you have. Now, if you install an application in your tenant, you have to approve these scopes. So if you're an Entra admin, you have to approve that app getting that permission. This is what the Microsoft portal and the Microsoft documentation calls delegated permissions. The API calls them OAuth 2 permissions, but that's not really important. We're going to talk about these scopes, so what every app is allowed to do on your behalf. This approval is not always something that you want, especially if you're in the red team area, and that's why it's also nice that it's a lot of first-party apps. So these are the Microsoft apps, and for the Microsoft apps, we don't need to approve them. Like, it's a bit annoying if I want to start using Teams and the tenant admin has to approve the Teams application first because they already installed like Microsoft 365, so why would they need to approve Teams? So those are the Microsoft applications or the first-party applications. First of all, these exist in every tenant, so they are available in every tenant. They have the same permissions in every tenant. And because Microsoft decided what the scopes are for these applications, we don't need to approve them. So these are always there. The problem is that you don't really know which scopes that they have, because that's not something that you can query over the Graph API, for example. It's decided somewhere in the Microsoft tenant, presumably what kind of scopes these apps are allowed to have. So we need to figure out a way to actually know which scopes that they have. Because a lot of these apps are public clients, and that means that rather than using our own client ID and asking for approval from an admin, in a lot of cases we can actually get away with borrowing one of these Microsoft apps, and then we don't need to ask for the approval. So if I want to have a token with a specific scope, then I can just use one of the Microsoft clients that already has that scope pre-approved, and then I get a token with the approved scopes. There's one more feature I want to talk about, and that's family of client IDs. So this was actually a talk from Ryan when he used to work at SecureWorks a couple of years ago, also at Troopers. And then he talked about this undocumented Microsoft feature that basically there's a family of applications or a family of clients in OAuth terms. And the weird thing about these family of clients is that they can all share each other's tokens. So it's one happy family. They can reuse each other's tokens, which of course is pretty much a violation of the OAuth standard, because the OAuth standard says that every client should have their own refresh tokens. And if I can just switch client IDs and get a token with a completely different scope, then what's the point of having scopes in the first place? But basically that means that once you have like one refresh token for one of these clients in that family, we can get a token for all of the clients in that family, or for any of the clients in that family, and we can just switch between the scopes. And when we started this research, which was like in December, I think, last year-ish, there were like 38 known Foki clients, which is already a lot of scopes. But we'll see a few more Foki clients during this research, so we'll up that number a little bit as well. And basically what we wanted to do in the research, we wanted to do it the structured way. So we wanted to figure out all the first-party apps that exist, and then sign into all of them so that we can determine what the scopes are by getting tokens for all the resources. So first you find all the clients, then you use those to sign into all the resources, then you know all the scopes. Once we know the scopes, then we can also try these individual scopes to see if maybe some clients are like excluded from conditional access. If you just sign into all the possible methods with these first-party apps, then maybe we find some weird corner cases. And in the end, maybe we make some profit, or at least we can give a nice talk at Troopers, which is also a nice goal in life. So that's basically the approach that we're gonna talk through. And of course, there were some hurdles in the way that we're gonna also talk about.
So one of the first hurdles is how to get all those Microsoft first-party app IDs, because they are all GUIDs. So if you know a GUID, it's a very long string of letters and numbers, and you cannot just randomly try all of them. That would be a very time-consuming effort, and we wouldn't have this talk today, but more in like thousands of years. So what you can do is you can use sign-in logs, because in sign-in logs you see users using those apps, and that's actually what we do. I ran over a lot of sign-in logs, analyzed where are certain app IDs used, and then after that I requested some information through the Azure AD Graph API, so the old one still. And through this API it's possible to see in which tenant such an UID is residing in. And the most interesting tenant here would be SharePoint.com. That is basically the resource tenant of Microsoft where all the first-party apps live. There are a few exceptions, but most of them are in this tenant. And if we have a hit there, then this means we have a first-party app. You could also test this in your own tenant by registering either the app and then comparing if this is a multi-tenant app, or just comparing if it's like an app in your own tenant, so if it's like a first-party single-tenant app. The result of this was a long list of over 500 app IDs that we could now test on. And yeah, it's a bit a problem. So when Dirk-Jan looked at his environment, it was like not that number, because if you're just using the regular stuff, you will only see a few of those app IDs. But the more sign-in logs you see, the more environments you look at, the more funny apps you also see with funny names in them, as we will see later on. But one of the other objectives was to look at conditional access. And I don't know who here is very knowledgeable in conditional access policies. Just a quick refresher for that. It's basically conditional access, a feature of Microsoft Entra ID that allows us to enforce certain access decisions after authentication, so after the user used username and password. We have another set of conditions we can check on, and we can also limit it to certain applications, like we have seen now, and say, hey, you have to be on a compliant device, or you cannot use password to sign in. You have a certain authentication strength, like a FIDO key or something like that. You can always scope them to resources, user actions, and authentication context. That is something we won't discuss today. The first two we will see in our research. And depending on those things, you can then enforce certain access controls. You can say, hey, you have to have multi-factor authentication enabled, something like that, or the compliant device required, or even like block it completely. When you look at the two sets of policies that we have here, we have basically one that is all users, all resources, and we have one control defined here. On the other hand, we have a similar configuration. So we have all users, all resources, but we have one app excluded. And then we have a second one where we just have included this missing app that we excluded over here. So you would expect that both of those will yield the same result in the end, because it's basically the same configuration. We just have excluded one app and put it in another conditional access policy with the same conditions and everything. But if you look at the Microsoft documentation, Microsoft is already saying, no, no, no. As soon as you exclude any application from a conditional access policy, this means that this conditional access policy can be bypassed, not for like everything, but for certain things like certain scopes and for certain resources. So for native and single-page applications, we have different scopes we can now just access without the access control that we have defined in this conditional access policy getting applied. And for confidential clients, this is even more. So when we look at the different scopes that we have here, it's like user read basic all, that is like the basic information of any user, like you read the photo of the user, you can have the display name. So that's already some nice stuff you can read there. But people read all is also in there. We have user read all, group member read all, member read all. So it's a bit like in the old times with LDAP. As soon as you are authenticated in some way, you can read a lot of data. And this is just a documented bypass. Now let's have a look at something that is partly undocumented at the time.
Yeah, so there were also some conditional access policies which were excluded in certain cases. Like one of them is the company portal, and that's kind of a one that we found in an unstructured way, because the company portal is an application that you use to enroll your device in Intune and get your device basically compliant. So if you have a policy that you need to be on a compliant device, obviously you cannot have 100% coverage for that policy, because then how are you going to register register that device in the first place? How are you going to enroll it in Intune if you cannot get a token while the device is not compliant yet? So there has to be some kind of exclusion here, and that was the company portal app, because that's used to basically enroll your device and get it compliant with Intune policies. It's also used to actually tell you why your device is not compliant. So if we lose compliance, it's kind of useful if we can actually know why and we're not blocked from signing in that place. So it turned out that the company portal was a hard-coded exclusion, and it was always excluded from policies that required this device compliance control. However, it used to be that this company portal had quite interesting scopes. So if you look at the Azure AD graph, it had this user impersonation scope. So even if you had a policy for all resources that said you need to be always on a compliant device, you could just sign into the company portal, and then it would give you full access to all the Entra data, read-only access if you are a normal user. You could enumerate the entire tenant with tools like Road Recon, or even if you have an admin access, you could also modify things, because of course an admin can modify things over this API. So that was like a hard-coded exclusion, which was kind of found by just following the Intune process. And I mean, it cannot be compliant yet, so it has to be somewhat excluded. It was kind of logical. So if you look at the sign-in logs, if this happens, then you see that the sign-in is successful, even though the conditional access policy failed. So you need to be compliant. Oh, that failed, but the sign-in still succeeds because it's a hard-coded exception. So this is still there. Basically, there's been multiple people that found this. So I found it in like 2023 when I was doing Intune research, and I shared it like with a small group of people, because I'm like, well, this is a feature, but maybe not put it on the internet, because then people will abuse it. It was also publicly disclosed and later by Yuya at Black Hat Europe, and Microsoft also basically mentioned, oh yeah, this is not a problem, it's not an issue, this is how it works. Yet curiously, after it was disclosed, they still changed the scopes pretty fast, so then it suddenly was an issue, which is a bit of a recurring theme with MSRC, unfortunately. I keep telling them it's way more efficient if they fix bugs before they're public, but I don't know, they don't always want to listen. So this still works, and there's still some data that you can query, but basically they removed this user impersonation scope, and then you only can query very specific attributes now. So it's still a bypass, it's just a less useful bypass in this case. Another one that's quite interesting in some cases, or that is with some more advanced conditional access policies, is the device registration. Maybe you know, if you're familiar with conditional access, that device registration needs a separate policy. A policy for all resources will not cover the action of registering devices, again, because you cannot have most of the controls when your device is not yet registered. So often this is forgotten, and then you have multi-factor for everything except for the registration of devices, because they forgot the extra policy. But what's interesting about this is that the device registration resource is also used for other purposes. So for example, if you're enrolling a Windows Hello key, that's also covered by the device registration resource. So in more advanced scenarios, if maybe you're enforcing phishing-resistant authentication or other authentication strength policies, then you also need to apply that to the device registration, because otherwise I can authenticate with regular MFA, get a token for the device registration service, then enroll Windows Hello for Business key, and that passes like the phishing-resistant MFA. So that's also kind of a weird bypass. Anyway, this is all the unstructured ways that you just randomly find if you're researching all these protocols and all these flows, looking at the sign-in logs. But we need to have a bit more structured way. And we also wanted to basically know like what every app is allowed to access, because before you can brute force basically all these scopes and see which ones come through with conditional access, you need to know what scopes these third-party apps have. So there's a few approaches there. And basically, how do you find out these scopes? Well, it's pretty easy. You just sign in to all the clients, like I sign into all the possible apps, and then I get a refresh token, and with that refresh token, I request tokens for all the possible resources, and if that succeeds, then apparently that client is allowed to have a token for the resources, and in the token itself, or in the response from Entra, I can actually see what scopes this token has. So if I sign into Teams, that's a client, I get a refresh token, I can use that for all these services, and then I can see the token scope, so I know exactly which permissions Teams has. So this sounds pretty easy, but it turns out that this signing into each client can be a little bit complicated. And basically that's why there's different routes of that, because I already did this approach a few years ago, but I had a very limited set of clients, needed to be a bit more structured. So in the end, I think we did like 4 rounds of this. And the first one was the simple way. So the first one, the goal was to basically sign into to all the clients. So you want to have this list of all clients. I received a lot of clients from Fabian that I didn't know yet, so that was very useful. And then there's this one very simple authentication flow. That's the resource owner password credentials flow, which basically means it's a username password authentication. So of course, if you have MFA enforced, then this doesn't work. But since it's my lab tenant, I don't have MFA enforced in all cases. So I can just send the username password to the API. I can specify the client, I can specify the resource, and I get my token. That gets me a refresh token, and with the refresh token, I can enumerate all the other resources for that client. So then I know the scopes, and then we knew the scope for all of these clients, basically. What you can also do is you can also reuse a refresh token from one Foki client. So Teams, for example, is a Foki client, and then you can try that with all the other client IDs. And if it accepts that refresh token, then apparently that client is also part of the Foki family, because otherwise we could not use the refresh token from a different app to do that. And then you find the Foki client. So multiple approaches. Or you sign into every client individually, or you just retry the refresh token that you get with all the possible clients. The latter approach only gives you new Foki clients, and the first approach works for most applications. So basically I wrote a Python script, and since Python is obviously the superior language, and I signed into all of the applications that I could find. But of course, if you do that one by one, then sign into one app, get a refresh token, use that refresh token for 1 resource, 2 resource, 3 resource, that's going to take a while. And since I'm not a patient person, I decided to parallelize it a little bit. The problem was that road tools wasn't exactly meant for parallelization. So I first rewrote the road tools authentication stack to support asynchronous authentication. So that means we can get a lot of tokens in parallel. So now if you look at GitHub, in the road-lib library component, there's this async authentication and async device authentication, so that use all the asynchronous methods. So you can use async IO HTTP, for example, to get a lot of tokens in quite a very short time. So that was round 1, did a simple way, and enumerated 219 apps. And we found 48 Foki clients, which was like 10 more than the 38 that existed at the time, and that requested like 300k tokens in, I don't know, like 10 minutes. So obviously the async approach is slightly faster than the one-by-one approach. The problem is that this ROPC flow only works with public clients, so apps that are marked as a public client. So public clients are like apps, mobile apps and desktop apps that run like on your device. But not all the apps are public clients, so the ROPC flow doesn't work for all of the apps. That means we missed quite a few applications. And quite a few apps, especially in the Microsoft world, are basically hybrid applications. So like many years ago, you had to register like an app as either a public client or as a confidential client, and at some point they made it possible to have like both configurations on the same app, and that means that the app is going to act as a public client for some of the redirect URLs on that app, and it's going to act as a confidential client for all of the other redirect URLs. So this, in the Entra portal, that would look as follows. It's probably a little bit too small in the back to see, but if you have a web redirect URL, that behaves as a confidential client, and confidential clients you can only sign in if you have the client secret or certificate for that app. Unfortunately, I don't have these for Microsoft apps. That would be quite interesting if I had those. But we don't have the client secret, so we cannot sign into confidential Microsoft applications. But if you have a single page app URL, or you have a mobile and desktop app URL, those act as public clients. So depending on the redirect URL I use in my authentication flow, I might be allowed to authenticate, or I might be told you're a confidential client, so you need to use a client secret. But for the public clients, basically it's fair game. Now the only problem is that we cannot query like what the actual type is. So you can see this for the apps in your own tenant on the application object, but for service principals, like third-party apps, you just can't see this. So we don't know what the URL types are. That's quite annoying. The other annoying thing is that if you use a redirect URL, it means that you normally have to use interactive authentication. So you have to use authentication like in a browser with the authorization code flow, which means it's not just a very simple API call that you can get that token with the username passwords. And of course, spawning a browser every time, even with some automation like Selenium, is quite slow and it doesn't always work. So ideally, we avoid that. The solution for that is actually primary refresh tokens. So I've covered these already a couple times, but primary refresh tokens are single sign-on tokens, which means that we sign in once with single sign-on, and afterwards we can use them for any application that exists. And with the PRTv3 protocol, we can actually specify a scope parameter, so then we can also switch between different scopes, different resources. Talked about it last year with the macOS talk. And then we can also specify the redirect URL, because the authentication broker, which is the component on Windows and on other operating systems that uses that primary refresh token, it also supplies the redirect URL parameter. So that means it will trigger either a confidential flow or a public flow, depending on the redirect URL that you use. And the nice part is that it also works for both native app URLs and also for single-page app URLs. So we don't need to do the whole single-page app flow, which is even more complicated than the native app authentication. So primary refresh tokens allow us to sign into every app, and as long as the app has one URL which is allowed, then we can do it. So the approach becomes slightly more complicated. Basically, we have our credentials. With those credentials, we ask for a primary refresh token, and then we use the broker flow to basically get a normal refresh token for each of these clients, and then we do the same thing. We iterate over them, and we get a token for each of the resources, look at the scopes, and then we have our result. There were various sub-rounds in this. So again, we cannot query for which URLs we can actually use this. So first I started with one of the obvious ones. So this one is almost always like a public client. There's one app in the Microsoft world that actually has this configured, but it's still a confidential client, which doesn't make any sense whatsoever. Any non-HTTP protocol, so any URLs that start with like MS-auth, they are kind of by definition mobile apps or native apps at least, so they will probably work. Any app on localhost is also quite likely to be a public URL, so you started with these. And in the end, I was like, okay, well, there's probably other URLs, so in the end, I just tried all the possible redirect URLs that exist of each application until I found one that worked, and if you didn't find any that worked, then apparently it's only a confidential client. So at the end of round 2, we had 229 clients. We found 50 Foki clients, so 2 new Foki clients that were apparently hybrid clients, and the number of tokens was up to like 600K. Round 3, we ran into a bit different problems. So what I did first is just ask a token for the Microsoft graph first, because I want to get a refresh token, but you cannot tell Entra, I only want the refresh token. You always have to also ask for like an access token. So then I changed it, so I actually asked for the OpenID scope, and that means that I get an ID token and a refresh token. So then if the app is not allowed to get a token for the Microsoft graph, then we will still get a token. But then we ran into the next problem, because apparently not every client has the OpenID scope allowed. So there were still quite a few apps that had neither graph permissions nor OpenID permissions, so we couldn't sign into those. And then the solution is to just do more brute forcing. So we just try to sign into all the possible resources, and then if an app, for example, only has scopes on Azure Management, then we will get a token once we hit Azure Management, then we have our refresh token, and then we can continue doing the enumeration. So this increased the total number of clients from 229 to 245. So a few more clients by basically fixing all of these weird scopes. Then there was another interesting thing, and those were all these redirect URLs that you see that start with like BRK. So this is weird, because this is a weird prefix. This is BRK, then this looks like a GUID, and then there's a URL. So what's up with these things? If you try to use this as a redirect URL in your authentication flow, then it's actually going to tell you, like, oh, you cannot do this because it was on a request that wasn't for brokering. It's only for brokered apps. I don't know what this is. What are brokered apps? The documentation about this is quite sparse. I mean, there's not really, I don't think there is even an official documentation to tell you how to do these brokered requests. It's not in the like the OAuth documentation from Microsoft. But it turns out these broker redirect URLs are basically for apps that get tokens on behalf of other apps. So if you see the broker redirect URL, it always starts with a hard-coded broker prefix. And then you see the allowed client ID. So this client ID is allowed to get a token for this like sub-application or sub-client, and it's allowed to do that from this origin. So in this case, what you actually see is, or this app, it's running within the Azure portal. So the Azure portal uses a lot of sub-applications. You sign in once to the Azure portal, and then you sign into like a sub-application, which uses the refresh token you get from the portal to sign into that up apps. So you mainly see this also on the Azure portal, so that's the main broker client. You also have this for Office, so then it will be the client ID of Office, or this weird like multi-hub specifier, which includes another family of clients probably that are specific to Office. Teams also. So that's kind of a new flow. And this is the broker authentication flow. So what it means is that you sign into a broker client, like you sign into the Azure portal, and then the broker client gets a refresh token, and then it requests tokens for all these sub-applications or nested applications, nested clients, like the AD Ibiza UX, the devices blade, the billing blade. They're all like sub-applications within the Azure portal that use the refresh token from your initial authentication to get tokens for that sub-part of the portal. This is kind of like a sort of Foki light, because with Foki we had all these apps and we could just reuse the client ID between them. But this was like brokered authentication, so you can use the refresh token for sub-apps. So we thought, well, it's not Foki, let's call it like Broki, like for brokered client IDs, or Noki, like network of client IDs, because you go from one client to the other clients. That's kind of nice. Unfortunately, it turned out that there was already a name for it, because it's sort of documented if you know where to look, and it's called Nested App Authentication, or NA. I like Broki way more. So you can find it here. It just still doesn't tell you exactly how the request looks, but it's sort of documented. And just to show you that security researchers are not very original, I was talking with Fabian, and we're like, oh, yeah, we can use the name Broki. And then like a couple of weeks ago, I was talking with Hope from SpectreOps, and they were also looking at this, and they're like, oh, we thought it Broki. I'm like, oh, okay. So everyone thinks alike, apparently, and we all want funny names. But unfortunately, it's called Nested App Authentication. I like Broki way more. Let's stick with Broki. So of course I also added this to RoTools, and you can do this brokered authentication with RoTX. And that means that first you have to get a token for the broker application, so you have to get the refresh token for the Azure portal that has to use this interactive flow, or you can use a primary refresh token if you have that. And then you can kind of exchange it for like one of these nested apps. So you say, okay, I have this refresh token, and I want to authenticate to this client. I don't know which client this is, but it's one of these sub-applications. And the broker client is the portal, so this is the GUID from the portal. And this is the redirect URL, so it starts with that BRK, with the client ID, and then with one of the prefixes that's allowed. And I want a token for the Microsoft Graph, and this is the origin. So this is a lot of manual stuff, and I was like, well, okay, this is a bit annoying. And since all the output from this research kind of went into RoTools, so actually RoTX knows about all these apps, it knows about the redirect URLs, it knows about the authorized client IDs, so I'm like, why not do this automatically? So there's this auto broker flag, and then it will just tell like, oh, you want a token for this client? Okay, well, I know which clients are allowed to that because I can see that in these broker URLs. I also know which origin it's allowed from, so I just add these parameters automatically based on this client ID, and then it will get you a token. So the only thing you need to do is refresh token 2. If you have Azure Portal token, then you specify the client ID of the target application, you specify the scope of the target application, then it will fill in the broker and the origin on your behalf, at least if it can find the correct client. So it was kind of round 4, so we found all the brokered clients as well. You sign into the client ID that's allowed to get a refresh token for those brokered apps, to get a broker refresh token. And then we use the broker client flow to get a token with the correct origin, to get a token for the broker client. It's a lot of stuff. One thing is that brokered apps don't get their own refresh tokens. So if you use a refresh token from the Azure portal to get a token for one of these sub-apps, then it will you will not get a refresh token for the sub-app. You need to keep reusing the Azure Portal refresh token for all of the sub-apps and all the resources that you want to authenticate to. So they don't get their own refresh tokens. You have to keep using the original refresh token. So that was round 4, and round 4 was also like the last round. So in total, we found 537 apps, all first-party apps that have some kind of predefined scopes. We found 52 Foki clients. Actually, now it's 51 because Microsoft killed one last week. So they removed one, and now there's one less. So 51. And in the end, we got like 840K tokens almost, which took 25 minutes. So I didn't calculate the tokens per second, but it's quite fast. Luckily, I remembered to turn off my Sentinel forwarding, because when I did this project a few years ago, I did all these tokens, and then after, oh, your Sentinel usage is... And I guess if you request like 1 million tokens, or a few million tokens, then it gets expensive. So if you test this, make sure to turn off your log analytics forwarding, that kind of stuff. I do want to give a shout out to a different project. So while we were doing this, and after we already submitted to Troopers, there was also this tool, a Graph Pre-Consent Explorer, that was released from Compass Security. And this also contained a lot of these clients, also contained the broker flow, and it also had quite a few Foki clients. So that was kind of parallel research. I don't want to pretend that we were the only ones that did this. So also check out this project. The limit is that this project only did it for graph permissions. So in the end, we did it for all the possible resources, like all the APIs we could find, not only for graph. But there was also this very nice project out there that was kind of like existing at the same time, which is something that happens when you do research. These days, there's fortunately more people doing Entra research, and then sometimes you do parallel research, or you did someone that someone else was already doing. All right, let's go to the conditional access analysis.
Yeah, so we have a lot of tokens now, and still we don't have any idea what conditional access has to do with them, because Dirk-Jan just ran them without any conditional access policy, no MFA requirement, nothing. So our research also started from two sides, basically. My side was more the, hey, let's get into all the different conditional access policies. And Dirk-Jan's was more like, I can do this really fast. And so I had a bit of a different approach in the beginning, because I wanted to do pretty much the same. List all of the first-party apps, list all of the resources that are available, list all of the available scopes, and then I decided, hey, these are too many. I will only focus on the Foki applications in my research, because I now can use a single refresh token I get at the beginning and test all the conditions after that with this single refresh token. And what I did in addition is that I defined conditional access use cases. So I had a lot of different use cases defined. Baseline use cases where I had like no MFA or MFA required but present in the token. But also then for the bypass detection, I had stuff like, okay, you have MFA required, but you have a token that has no MFA in it. And now we try this out. And I had this for MFA required for all applications, but also with the combination user action register device, user action register security information. I also tried the single app exclusion, since it was a documented bypass by Microsoft. And of course, the compliant device, one of the most interesting ones, I think. Hybrid device required, global secure access required, network location required, and authentication strength with passkey required, one of the last additions we did together. So this is only a small subset of possible conditional access policy definitions, but I think it represents most of what companies are using today. And for those use cases and for the Foki apps, I reran all the tests again with different users to simulate exactly that. And since PowerShell is, of course, the best script language out there, I wrote my tool in PowerShell. At the time, I not yet had talked to Dirk-Jan, so I also enumerated a lot of Foki clients. Then I wrote a second PowerShell script, and that let me test all those Foki applications and all the known resources. And then, yeah, it was like, okay, write all the data to a JSON file and search for anomalies in this JSON file. While I was investigating this, I did some other research on the site, and this brought me to a little rabbit hole. And as you can see again, researchers think alike. We also like the same memes. And this was basically not only the application ID and the resource ID were interesting for bypasses, but also the requested scopes. I looked into the Microsoft Authenticator app because there was a strange behavior. You could have like an uncompliant personal device, but still you could request a passwordless authentication method on this device in the Authenticator. And a bit of background, basically the passwordless authentication registers a device, you get a PRT, and based on this you connect to company resources. So it basically should be prevented by the conditional access required policy, but it wasn't. So I looked into what the app is actually requesting in here, and I found that it has requested the user authentication method read. And this was just granted for graph. Other scopes I tested with the same app and resource did not work. So that meant Microsoft had implemented a bypass in here to allow a certain scenario. And let's have a look at this configuration. Basically, I have a user here that must be compliant in MFA. It has a so-called temporary access pass. With this temporary access pass, I will have an MFA token. So this is not the problem here. The compliant part will be the interesting one. You can see in the what if that it requires a compliant device and MFA. And in here you also can see that I have like no exclusions, so it's scoped for all resources. I wanted to make sure that it's not some weird thing with the like basic scopes that we have seen earlier by Microsoft. And when we now sign into something like Outlook, we will get a nice error message for this user as expected. So we have MFA through the tab, but we don't have a compliant device, and there you can see, hey, you have to go somewhere else because you are not on a company compliant device. That is how it should be. But when I then do the same request using token tactics, using the authentication flow, the authorization flow, and only request the user authentication, the user authentication read, or method read, I do the same sign in interactively, username, password, or tab. You will see, hey, do you want to sign in, Authenticator app? Yes, please, and no error, but I get the auth code, and this I can now use to exchange it for a refresh token. Let me get that from the clipboard, and there you can see it worked. And now I have a token with a refresh token in there, and if we look at the access token itself, since we still can parse those, they are not yet encrypted. We see it's for Microsoft Graph, and we have tab MFA for the Microsoft Authentication app, and this is the user. So it worked as expected. If we now go a bit forward, you can see I even can connect to the Microsoft Graph with this access token, and in there you can see the different scopes I got. And the most interesting one in this case was the authentication method read. Let me just jump ahead a bit. In here, you can now see I was able to read all the registered authentication methods for a certain user. This is not the biggest problem if those authentication methods are like a FIDO key or something, because then there is not much information of value for me as an attacker. But if you have registered like a mobile phone in here or an email address I shouldn't know about, then this can be a problem because this gives me an attack vector. Microsoft has fixed this by now. They decided, yes, this is a problem. the interesting thing is how they fixed it. You still would get the access token with a scope in there, but if you then go to the actual resource, Microsoft Graph, the resource will say, nay, you don't get that. My best guess why they implemented it like that is since the authentication app is on millions of phones and they have to update the authenticator app to change what to request, they decided, okay, we will allow the initial sign-in with the scope still, so you don't get an error message on your phone, but we will block it in the backend. The whole thing I reported in January to MSRC, and in about April they acknowledged and fixed the whole thing and also awarded a bounty and some nice points. So this was the initial bypass I found through this research. And then we got into more iterations of the whole thing. I'm not sure if I only did 5 like you did. I think there were a few more because I also extended the tooling of token tactics, built into the auth code flow, added some optimizations to run the whole thing in so-called PowerShell run spaces. Same thing as Dirk-Jan did, so having parallelization in there is very, very important. And I also imported a lot of scopes that Dirk-Jan found in his research that I could test now. I also switched over from a JSON file to a SQLite because JSON, looking for anomalies in there, that's a real pain. And SQL is at least somewhat better to request information from. My basic flow was like, okay, I get some kind of refresh token interactively. Since I use only Foki apps, I can use the same refresh token for all the different Foki apps and for all the resources I have. But now I also have to loop through all the combinations, including all different scopes that are available, because it could be that there is another scope-based exclusion that I can find only by requesting this particular scope, making the amount of different variants of this quite high. And since I also have quite a few use cases, it takes some time to run all those. There were also other challenges. So initially, I also had to find some way to get a refresh token while bypassing the conditional access policy, because I wanted a refresh token in the scenario no MFA, where no MFA was present. So I couldn't just like sign in. I had to look for one way to get past it. I found something, and we will see that there is like a few app IDs that just don't do any conditional access. So they were an easy way to get those initial refresh tokens. And also another challenge was that the V1 endpoint in Entra and the V2 endpoint in Entra, they behave differently. And this was after I reran some tests and I switched the version from 1 to 2. I saw that the outcome was different. So first of all, I thought, okay, something was fixed. Then I got back to V1 and it was the same output as before. So I was, okay, there's something here. And you can see this in the last example. I first try with the scope OpenID and the V1 endpoint, and I get a failure saying, hey, I'm not in the required state, something, something. And then I try the same thing for the V2 endpoint, and hey, I got a token. So this means now I doubled the whole tests again, because now I don't only have to test for V1 and just be fine with it. No, I have to test V1, V2, and that for all scopes and for all resources and all applications. And it got a bit longer in time run. I'm still now down to half an hour per use case. I'm pretty good with that, but still, yeah, it took some time. One other thing, the whole reporting is still a manual process. So of course, you get the output, you have the SQLite, but you still have to do something on your own. behind that. So that's something I want to challenge in the future. And also, while setting up the use cases, you need to have patience. And like Dirk-Jan, I don't have much of that. But it will skew your results. So setting up a conditional access policy, creating a user and signing it, and then just deciding to run the tests immediately, you will get a lot of nice results. But none of them are really results. It's just because it takes at least an hour that all Microsoft endpoints know about this new conditional access policy, the new user, and I think time's up.
Yeah, there was also like an instance on Teams where I sent Fabian a message. Then I removed it again, and he said, "Oh, did you just send me a message?" I was like, "Yeah, I found something, but let's wait half an hour." And then I was like, "Oh no, it didn't work after all." A big disappointment. You think, "Oh, this is a nice bypass," and then, "Oh, fuck it didn't sync yet."
Yeah, I think the first week of testing, there were quite a few of those, and after that I decided, okay, I will set this up, and tomorrow I will start with the actual research. Otherwise, I'm too excited, and then I'm too down. That's not worth it. I think the battery was empty.
Yes, for some reason, yes.
No worries. Yeah, too much words. It's battery per word. Yeah, so we already talked about the device registration service resources not protected by network or compliant compliance requirements. For the network part, I also checked with MSRC, and they are also thinking it's still okay that if you block all resources from anywhere, that you still be able to register a device, because you cannot scope network location to this policy, to this user action. So the only option to protect your device registration service is by using MFA and authentication strengths. There are some newly documented bypasses by Microsoft. The ZTNA Network Access Traffic Profile, or Global Secure Access as the marketing name is, has also some bypasses. That's, of course, if you want to connect from a non-compliant network to this initially, you have to have some bypasses, otherwise you can't connect. The HAN-ACK problem. And Microsoft was kind enough in this case to really document this, and it's really extensively covered in the documentation. And I think there's one page missing. Let me just, I forgot to unhide it. Those were my favorite resources, because those resources basically don't have any conditional access enforcement whatsoever. This works as expected, and it only works for the V1 endpoint. So if you're using V2 endpoint, you will get completely different results. This is all protected, but with the V1 endpoint, there are some exclusions in here, and you can just request refresh tokens. This made a lot of the research possible for me, because otherwise I would have been stuck immediately. Also, Dirk-Jan found out if you're using the old control, so not conditional access, but enforcing user-based MFA, then this is also not true, so then you are protected as well. So basically, conditional access has exclusions that you don't have if you either use the V2 endpoint or if you enforce MFA for this user in particular.
So for user, MFA is more secure. For MFA at least.
Yeah, maybe not the recommendation you should give your customers or yourself. But, And then we also have one where we just waiting for final confirmation that it is working as designed. Initially it was like, yeah, works as designed. Then they came back and were like, yeah, we want to test a few things. So maybe we will give you something there in the future. Since we are almost out of time, let's talk about plans for the future. Run this in a more automated way. So currently it's manual stuff. I want to do this more automated and refresh the results on a regular basis. Get more output from Dirk-Jan's research into that, and For detection approaches, we already have seen this before, but basically, if you want to look in your logins for such stuff, you can use the log analytics and just check if there's any failure in the conditional access policy, but the conditional access status is success. That means that something was excluded. It doesn't mean that you can alert on it because it's something that was intentional and it's not an attacker or something, but still you can see what is excluded. And yeah, basically as a result of that, we not only have a completely rewritten road tools parallel stuff and a lot of information in there, but we also have a nice little website. Let's switch over there.
So we put everything in the GUI. And here you can find all the scopes for all the possible apps. So it's on entrascopes.com, and it is a nice design. And I didn't do any of this. It's all Fabian making this web app. So you can also find all the bypasses, so you can filter on that, but you can also find like, I want a token with, for example, mail.read on the Microsoft graph, and you just say, okay, mail.read on graph.microsoft.com, and it gives you all the clients that have that with like a visual way of searching. So this is already in like in RoadTX with the command line option, but of course having a UI and having all these apps in there, it's more quite nice. You can search all the apps. You can also filter between Foki clients, non-Foki clients, depending on what your scenario is. And you can figure out all these apps what the allowed scope is or not.
And we also have the ProKey apps in here, and even like an explanation. Hey, this can be brokered by the Azure portal, so you don't have to know which app ID this is by yourself. And of course, you can also filter this up here. It's named Nested App Authentication here, but maybe we will add a little ProKey here after the talk. So yeah, basically the conclusion is conditional access is really complicated, and even if you think you know it, there are some edge cases where documentation is lacking or just non-existing. And whenever you can, try to protect all the resources in your conditional access policies. Do not do exclusions. Sadly, many of the times you have to do some exclusions, and now you know that there are exceptions of the rule.
Yeah, just a shout out to some other research. I already mentioned the family of client IDs, Graph, Pre-Consent Explorer, also the sites from Merrill with the Microsoft first-party apps, which is also good input that we used, and of course Token Tactics. That was also one of the first apps that like did this Foki before it was even called Foki. All the refresh token, different scopes, kind of bypasses. So also make sure to check those out. And of course, all the first-party scopes are on the entrascopes.com website, and they're also part of Road Tools. So if you want to use any of them, you can already do it because that's already on the public GitHub. And I don't think we'll have time for questions. So we'll just leave here and have some time for the next speaker to set up. But we'll be around today, so if you have any questions, just catch us today.
Thank you.
Thanks, guys.